let's talk about gases and the different gas laws. So gases have different properties like volume, pressure, and temperature. Volume, it's the space occupied by the gas particles. Pressure, that's equal to force per area. So force per area. So it's a measurement of the amount of force exerted by gas particles per area. And temperature, that measures the kinetic energy of the particles of gases. Now, these properties are related to each other, and this will be described by the different gas laws. Let's start with the relationship between volume and pressure. According to Boyle's law, the volume of gas is inversely proportional to the pressure exerted by the gas, that is at constant temperature. Again, here, these two properties, volume and then pressure, are inversely proportional to each other. Now, we can write this relationship using this equation. Again, the volume is inversely proportional to the pressure. So, merong constant because, again, they have a proportional relationship. Now, we can rewrite this one as this one, or is equal to P1 times V1 is equal to P2 times V2. Now let's see how this works. Again, when here we have from 1 atmosphere to 2 atmosphere, the pressure increased by a factor of 2. What do you think will happen to the volume? Again, they are inversely proportional to each other. So when we double this one, this will be cut into half or 1/2 because the inverse of 2 is equal to 1/2. So this will so if we increase the pressure to 2 atmospheres, the volume will decrease to 11.2 liters. Next, from 1 atmospheres to 0.5 atmosphere. So here we have decreased our pressure by 1/2. What do you think will happen to the volume? The inverse of 1/2 is 2. So here the volume will increase by a factor of 2. This will become 44.8 liters. Okay, again, that's what we mean by their relationship with each other. Let's see how this works on this problem. 7.50 liter gas has a pressure of 0.750 atmosphere. Determine the volume after its pressure is increased to 1 atmosphere at constant temperature. Here we can use this equation. P1 times V1 is equal to P2 times V2. So here just plug in the given values. So the initial pressure is equal to 7.50 liters. Then 0. Sorry. So here we're looking for the pressure first. So for the pressure, we have 0.750 atmospheres, and then yung volume is equal to 7.50 liters. Then yung pressure, that's 1 atmospheres, and then yung final volume is unknown. Again, we're looking for the value of V2 here, so divide both sides by 1 atmospheres. 1 atmosphere. Now here what's left is the V2. Then for the rest, you just need to solve this one. We have 0.750 times 7.50 divided by 1. That's the same. So we have 5.63. 5.63. Then what's left here is the liters. So that's the answer for this one. Let's proceed to this example. A sample of NO2 has a volume of 6 liters and a pressure of 0.98 atmospheres. What is the new pressure of a gas if it occupies a volume of 9.50 liters? Again, here the initial, we can use this formula. P1 times V1 is equal to P2 times V2. Here the initial pressure is equal to 0.98 atmospheres times the initial volume is equal to 6 liters. Then the final volume, the final pressure is unknown. So you have P2 times, how about the final volume is equal to 9.50 liters. Again, we're looking for the value of P2, so divide both sides by 9.50 liters. What's left here is P2. Then for the rest, you just need to solve this one. We have 0.98 times 6, then divided by 9.50 is equal to 0.62. Now here we have a 1 sig fig, so we can round this one to 1. Okay, 1 liter. That's the answer for this one. No, sorry, this is not 1 liter. This is pressure. And if you look here, we can also cancel this one. What's left here is the atmosphere. Okay, that's the unit for the pressure. Let's proceed to the relationship between the volume and temperature. The relationship is described by Charles' law. It states that the volume of a gas is directly proportional to its absolute temperature in Kelvin. So here, dapat ang temperature must be converted to Kelvin if it's given in degrees Celsius or degrees Fahrenheit. So here we can, again, they are directly proportional to each other. We can write it as this one. So we have the volume is equal to some constant times the temperature, or this one, or this one, or this one. Okay, again, they are directly proportional to each other. So here we increase the temperature by a factor of 2. What do you think will happen to the volume? The pressure will also increase by a factor of 2. That's from 1 liter to 2 liter. Next, what if we increase the temperature by a factor of 3? What do you think will happen to the volume? The same thing, increase by a factor of 3. This will become 3 liters. Let's see how this works on this problem. We can use this equation. We have V1 times T2 is equal to V2 times T1. Here, the initial volume, that's 15 liters, 15.00 liters. Now for the next one, be careful because this is the final temperature. The final temperature is this one, right? This is the initial temperature. Again, be careful with this one over here. So again, this must be converted to Kelvin, and we can convert this one, 20.0 degrees Celsius. We can convert this one to Kelvin by adding 273.15. Now if we add that one, we have 20 plus 273.15, it's equal to 293.15. 293.15 Kelvin is equal to V2. We don't know the final volume. How about the initial temperature? The initial temperature is equal to 45 degrees Celsius. The same thing. This must be converted to Kelvin. So you add the number 273.15. Again, 45 plus 273.15. Sorry. 273.15. 273.15. So we have 318.15. 318.15 Kelvin. We're looking for V2, so what should we do? Divide both sides by this number, 318.15 Kelvin. 318.15 Kelvin. What's left here is V2 is equal to, then you just need to solve this one, 15 times 293.15 divided by 318.15, and so we have 13.8. Okay, 13.8. 13.8. What's left here is liters, so we have 13.8 liters. That's the answer for this item. Next, the same problem about Charles' law. We have V1 times T2 is equal to V2 times T1. Here, the initial volume, that's 635 ml, 635 ml times the final temperature. Again, you look for the final temperature. That's from 34 degrees Celsius to 25 degrees Celsius. Again, just look for these key terms. This is the initial, this is the final temperature. You have 25 degrees Celsius. Again, convert this one to Kelvin, 273.15. Again, 25 plus 273.15. We have 298.15. 298.15. Let me check. 298.15. 298.15 Kelvin is equal to the volume. What is the new volume? So that's V2. Then what is the initial temperature? That's 34 degrees Celsius. 34 degrees Celsius plus 273.15 34 plus 273.15 is equal to 307.15. 307.15 Kelvin. Then the same thing, divide both sides by this number to get V2, 307.15 Kelvin, 307.15 Kelvin. V2 is equal to the same thing, multiply and divide 635 times 298.15 divided by 307.15 is equal to 616. 616 ml. Okay, that's the volume on this problem. Okay, next let's discuss the relationship between temperature and pressure. So here, according to Gay-Lussac's law, so the pressure is directly proportional to its absolute temperature. So the same thing sa previous law. So here, the pressure again is directly proportional to the temperature. Then that's for pressure, then the temperature. We can have this formula. Okay, what do you think will happen? This must be pressure. This must be pressure ATM. Okay, so from 30 Kelvin to 60 Kelvin, that's by a factor of 2. What do you think will happen to the pressure? Again, it's the same thing. They are directly proportional. That's also multiplied by 2. So we have 2 atmospheres. Then here, the same thing, multiplied by 3, multiplied by 3. This will become 3 atmospheres. Okay. Then we have this formula for the Gay-Lussac's law. Let's apply this on this problem. Again, we have P1 times T2 is equal to P2 times T1. Here, a gas is heated from 75 degrees Celsius to 85 degrees Celsius, and the volume is kept constant. What is the final pressure if the initial pressure was 1.5 atm? So again, this is the initial temperature, this is the final temperature, and this one is the initial pressure. Okay, so the initial pressure is 1.5 atmospheres times the final temperature is equal to 85 degrees Celsius. Again, this has been Kelvin. 85 plus 273.15. Let's do that. 85 plus 273.15. We have 358.15. 358.15 Kelvin is equal to the final pressure. Again, we're looking for the final pressure, and then times the initial temperature. We have 75 degrees Celsius. Again, let's convert this one to Kelvin. That is 75 plus 273.15. We have 348.15. 348.15. Again, divide both sides by this number to get the value of P2. 348.15 Kelvin. 348.15 Kelvin. Then P2 is equal to, then you solve this one. We have 1.5 times 358.15 divided by 348.15. We have 1.5. Okay, 1.5. Wait, this should be not 1.5 because now let's check this one. We have 358, 348. Initial temperature 358. So